So this week, like I said, is review and test week. Okay, so today will be a review day, kind of going back over what you need to know for the test and kind of how to work your way through it. And then, like I said, I'll give you some work time in class as well so that you can work through that a little bit. And then your test is Wednesday. Thursday is the Chapter 5 test. And go from there. Okay, we'll start Chapter 6 next week. So let's start though with, there we go. That's what I wanted to start with. Any questions from the synthetic division worksheet that you want to go over? Anything that you got stuck on in terms of how to do synthetic division, process, what the answers mean, any of that stuff? Any questions that you have at all? Nothing? We're okay? Feeling okay on synthetic division? Good news is, on the test, you will not have to do long division. You have the option. If long division makes sense and you want to do it, that's fine. But you'll have synthetic division as an option as well. Okay? So if there's no questions, then I'm going to keep moving on. This worksheet, by the way, is due today. Okay? This is due by midnight tonight, so make sure that you get that finished up, get that turned in. The other stuff, remember basically the final due date to get stuff in for this chapter is pretty much tomorrow at midnight for you guys. Okay? It's always the day, by the time you take the test, is basically the final due date. So make sure you get anything if you didn't do the last Delta math on synthetic division, those types of things. Make sure that stuff is all taken care of here before you take the test. Okay? Here's kind of what we're doing today. Here's the chapter review. All right, so if you take a look, we'll go back to where I was before. So what you're going to need to be able to do is, in my opinion, two main things. And granted, that's a bigger picture, but if I give you any type of equation, whether it's in factored form already, or whether it's in standard form, whatever form, you need to be able to take that equation and tell me what the A value is, the end behavior, y-intercept, and then the big one, this entire chapter has been finding the x-intercepts and all the different methods to do that, okay? So that'll be a lot of the test is, given this information, can you find all the important features? The second part will be if I give you the graph, can you kind of work backwards to the factors and find the equation that it came from, okay? So we'll take a look at that today, but when do I use each method to find the x-intercepts? So first off, remember, if you have two terms, if you're looking at something and you're trying to decide, how do I factor this? If you've got two terms, it is probably one of these three options, either a difference of squares, a difference of cubes, or a sum of cubes. Okay, those are the three options that you have whenever you have two terms. If you have three terms, then it's probably that quadratic factoring that we've talked about, where the middle term is always half the degree of the first term. So you might have an x to the fourth as your leading term, and then the middle term would be an x squared, and then you have a constant term. Okay? Or it could be x squared, x, and a constant term. It could be x to the sixth, x cubed, and a constant term. Okay? But any of those is your quadratic factoring. You just keep working your way down from there. Then, if you have four terms, remember that's where the box method or grouping would come into play. Or you could use synthetic or long division if the box method or grouping doesn't work. Okay? If for some reason you're going through and it's just not working, and that does happen sometimes. It doesn't always work when you have four terms. So then you would have to either go to synthetic division or long division if that doesn't work. And finally, what we talked about just last week, if you have more than four terms, then you need to do synthetic division or long division. And the idea behind it is you need to do that. You need to keep working until you get down to a quadratic factor. At that point, you can then either use the quadratic formula or factor it from there to find those final two zeros. Okay? So if you have like a fifth degree function or a fourth degree function, something along those lines, there's a pretty good chance you're going to have to use synthetic division multiple times to get it down to a quadratic to find the first two or three zeros. and then from there, find the last two with quadratic formula, or if it's factorable, then you can keep going. Okay, so kind of a summary page of what to do when. Okay, so let's take a look at the next one. So let's kind of put this together. All right, so here's one of the examples I wanted to go over. So given the graph, there's our equation. I want you to find and verify all the zeros of this polynomial. Okay, so notice fourth degree, which means, by the way, how many total zeros should I have? What do we think? How many total zeros do I have? Yeah, what do you think? 4. Yeah, should have 4. Okay, fourth degree means you got 4 zeros. If you're looking at the graph, how many of those 4 are real? How many are real and how many are going to be imaginary? What do you think? Marissa, what do you think on this one? Very good. 2 real, one of them's at -2, one of them's at +4. There's the 2 where they cross, which means the other 2 have to be imaginary. Okay? Remember again, if that would have come up, let's say, and just touched the x-axis, remember that's a double root. Okay, there's actually 2 zeros in that spot. And remember, if it goes through and let's say it kind of just flattens out at the x-axis, that's a triple root. Okay, so don't forget about those. They're not in this problem, but just don't forget about that. All right, so in this scenario, I want to go through and find the zeros. I want to find the x-intercepts. I have 2 of them. I need the other 2. What's going to be my method of finding the x-intercepts on this one? What do we do? What do you think, Connor? Oh, you take a look. 1, 2, 3, 4. We've got 5 terms, which means if we've got 5 terms, we've got to work either synthetic or long division. Okay? So I'm going to take the first one here. We've got -2. I'm going to pull that over here. Along with, I'm going to do synthetic division. So we've got 1, -2, -7, -2, -8, and we are dividing by, let's say, -2. Okay, so we're going to do the synthetic division with the -2. Keep in mind, and I've mentioned this before, we haven't dealt with it a lot this year, but if there's ever a term that's missing, make sure you fill it in with zeros as a placeholder. So if there was no -2x here, if I just went from a -7x squared to -8, I'd have to fill in with a 0, okay, in that spot. So anytime you're missing a term, don't forget about that. All right, so we work through the process. Bring down the first term, multiply by -2, and then we add. I get -4. Multiply by -2, I get a +8. Add to get 1. Multiply to get -2. Add to get -4. Multiply, get +8. And sure enough, I get 0 as my remainder, which we knew it should have been the remainder anyway, because we knew it's on the x-axis, we can see it on the graph. Okay? So we knew we were supposed to get a remainder of 0. So remember, we started with a 4th degree, which means now these are the coefficients of a cubic function, which means I'm not quite there yet. So we got to get down to a quadratic. So now I'm going to take the other x-intercept that's off of the graph, okay, which in this case is 4, and we're going to go again. So same process with a different number. We bring down the 1. Multiply by 4. Add, I get 0, and that's okay, we can keep going. Multiply, I get 0. Add, I get 1. Multiply, I get 4. Add, there's my second remainder right there. Okay, so we confirm that that's also a factor. So in terms of zeros, I'm just going to start listing these off over here. We'll do zeros and we'll do factors. So first 2 zeros are -2 and 4. We got those straight off of the graph. -2, +4. And I know that there's 2 more imaginary ones coming from my synthetic division. Okay? Which means if I were to write this in factored form, that means so far, if I took this 4th degree function, come on. If I took this 4th degree function, x plus 2 then, remember it's always x minus whatever the 0 is. So we would have x plus 2 and x minus 4 as 2 of my factors. Well, there's your 2 factors to begin with. And because we did synthetic division twice, That means these are the coefficients of a quadratic. So this is 1x squared. There are 0 x's, so I'm not even going to put it down. And then you have a plus 1. There's your quadratic function from up above that we started with. There it is in factored form. Okay? And so now the only thing left is to take a look at your quadratic factor and see how can I get the final two zeros. If you can factor it, great. If you could use quadratic formula. In this case, I'm just going to take that x squared plus 1 and set it equal to 0 and solve it. Okay? There's only one variable in there. It's the x squared. So I'm going to subtract the 1 over. I get x squared equal to -1. Take the square root of both sides, and remember, whenever you take the square root, you always have to have a plus or a minus. Okay? So x equals plus or minus. What's the square root of -1? Parker, what do you got? What's the square root of -1?
That 1, 1.
You have the right idea. It's not. The negative comes out as? There you go. It's I. Okay? The square root of -1 is just 1i. Okay? So there are your final two imaginary zeros right there. You end up with positive I and negative I as your last two zeros. So if you put that back up here, I and negative I. There's the 4 zeros in this case. Any questions on this one? Because this takes you through using synthetic division in order to get to the zeros. One quick heads up so that you know, I think I mentioned this last week, but just so that you're aware, you will not have access to Desmos during the test. Okay, just as a heads up. So you won't be able to go into Desmos, but if you need a graph, you'll be given a graph. It'll already be there for you. Okay, just like this one was given. It'll be the same thing. Okay. All right, let's take a look at the next one. So then just a couple of these in terms of, here's a couple of different options in terms of how do I find these x-intercepts? How do I graph these? What do I do? So same idea, by the way, we didn't mention this all that much because we haven't used it all that much, but if you take a look, imaginary roots, I don't know if anybody's ever noticed this. Imaginary roots always come in pairs. They're always conjugates of each other. So if, for example, 1 minus 2i would end up being an answer. 1 plus 2i would also be an answer. Notice on the last one we just did, I was an answer. Negative I is also an answer. Okay? So just a heads up on that. Not that we're going to deal with that too much this year. That's one of the things that it's something to be aware of, but it's not by any means a main concept. Okay? So if we take a look, what are the roots of the following polynomials? If we go through and we do that, I'm going to take x squared plus 16, set it equal to 0, just like this last one that we just did, and now we solve from there. Subtract the 16 over, take the square root of both sides, therefore plus or minus, and same idea as what we did before. The square root of 16 is 4, but because it's the square root of a negative 16, it's 4i. And there's your conjugate pairs again. Positive 4i, negative 4i. Okay, there's your two answers. So if you had, in this case, you'd have a quadratic with 0 real x-intercepts. Okay, you got two x-intercepts, but they're both imaginary. So it's a parabola that in this case is opening up, that is entirely above the x-axis. Fourth degree, how would I factor that one? What do we do? Difference of squares, difference of cubes, quadratic factoring, box method, grouping, what do we do? What do you think? What do you think? Connor, what do you think?
Quadratic.
Yeah, this is quadratic factoring. X to the fourth, x squared. Okay, so we just go through and put our quadratic factors down. And we'll set that equal to 0. X to the fourth is x squared times x squared. Always start with the factors of the first term. Then you go to the other end, factors of your constant term. Now, there's quite a few factors of 36. You want the factors of 36 in this case that will add to 13. May tell me what they are? 9 and 4. Yep, you got it. 9 and 4, and they both need to be positive so that when you multiply, you get a positive 36, and when you add those together, you get a positive 13, okay? But now, we're not done. We factored. Now we're kind of right back to where we were before, okay? Back to the x squared plus 16. You could try to factor these. This would be like a sum of squares, which there is no such thing. And therefore, instead, I'm going to set each factor equal to 0. And if we solve, same idea, x squared equals negative 9. Take the square root of both sides. X equals plus or minus 3i in that case. There's 2 of our 4 answers. And x squared equals negative 4. Take the square root of both sides. And x equals plus or minus 2i. So again, in this scenario, 4th degree, positive 4th degree. Therefore, I know that it's a W shape. And just like the first example, opening up, and therefore entirely above the x-axis. You've got four zeros, just none of them are real. So none of them appear on the graph. So these I wanted to just kind of go back to the solving and the factoring and just kind of working back through some of that stuff again fairly quickly. And then, if we wrap this up, here's the last thing that I wanted to take a look at. So that's most of the, here's the graph. Now, I didn't go through y-intercept, all that kind of stuff, okay? But only because I'm hoping that you can do most of that at this point. The last part here is if you're given the graph, could you work backwards to come up with the equation? Okay? Could you work backwards to come up with the equation? And so if you take a look, and you had to do this on one of your Delta Math assignments, okay? You had to go back through and come up with, take the graph, write it in factored form, but then you also had to find the a value. By the way, by looking at this graph, what degree do you think that looks like? What degree graph am I dealing with? Abby, what do you think? Third? And is a positive or negative on this graph? What do you think? Yeah. This is more than likely, this is a cubic function with a positive a value because it's starting down low and generally increasing from there. Okay? Now, the problem is, I don't know what the positive a value is. Is it positive 1? Is it positive 1/2? Is it positive, 3/4? Who knows? So we're going to go through and we're going to figure it out. So I'm going to start with y equals, I'm just going to put a in there for now. And I'm going to write this in factored form because I've got the zeros on the graph. So your first zero is right here at negative 3, which means I can write my first factor as x plus 3. Then we go to the next part at positive 2, which means x minus 2. Remember, it's always x minus whatever the x-intercepts are, what the zeros. And then finally, here's our last one at 3, so we've got x minus 3. And so now, at this point, if you're trying to find the a value, the easiest way to do it, if you notice there's one other point that's on this graph, and it happens to be the y-intercept, okay? Or you could have picked any other point too if there's any other nice points. We're going to take that y-intercept. I'm going to plug the x-coordinate in for x, and I'm going to plug the y-coordinate in for y. Okay? That will allow me to figure out, I know that a is positive, now I can figure out positive what. Okay? So if we take that 18, let's plug it in for y. I'm going to leave a alone. If I plug 0 into each of these factors, I'm just going to put it down as an answer right away. So 0 plus 3 is 3. 0 minus 2 is negative 2. And 0 minus 3 is negative 2. Okay, so I took the 0, plugged it in for the x's, took the 18, plugged it in for the y. Now if we clean this up a little bit, I get 18 equal to, you get negative 6 times negative 3 is a positive 18. So 18a, which means, in this case, a turns out to be a positive 1. We knew it was positive, and in this case, it's positive 1. Okay? And therefore, if you're trying to come up with the equation of this then, so that means y equals, if a is 1, you can either put the 1 in there, or you can just leave it, since it is 1. And we had x plus 3, x minus 2, and x minus 3. And I'm okay with if you leave it like that. If I asked you to do this in standard form, though, by the way, what would you do? what would you have to do? We're not gonna do it, I'm not gonna worry about it, but if I asked you to put that in standard form, what would you do, Sophia? Yeah, just multiply it all, take the first two factors or FOIL them out, and then take that answer times x minus 3 and distribute through. Okay, just a whole bunch of distributing. Multiply that whole thing out. Okay? How we doing? That's pretty much what you need to be able to do. Okay, now granted, obviously there's different parts and things along those lines, but that's the main ideas, at least, of what you need to be able to do this week on the test. Okay? So here's what I'm going to have you do for the rest of the class. Okay, I've got a bunch of review problems here for you. So I've got a couple of different worksheets, and one of them's called Writing Polynomial Functions. The other one doesn't really have a name. I just threw it together over the weekend, trying to find different problems that I liked, that kind of fit. This Delta Math, just as a heads up, this is not an assignment. Okay? This is a synthetic division if you want some practice, working your way through. Okay? So this Delta Math is just a review, not an actual assignment that needs to be done and turned in. So that's optional if you think you need it. Okay? So let me give you the two things that I have here quickly, and then I'll turn you loose and let you work on it. So there's the first one. This will take you back through a lot of the previous stuff. Is this an even or an odd degree based on the graph? How many total zeros do you have, real zeros, that kind of stuff. Writing the end behavior, okay, that kind of idea. There's some factor form, but so this is a good idea of everything that you're gonna see. Then let me hand out the second part to you real quickly. This one I'm going to modify just a little bit, because there's some stuff on here that we didn't cover this year. The front page is pretty straightforward. Describe the end behavior on numbers 1 and 2. Numbers 3 and 4, I said divide. You can either do it with synthetic division or long division, totally up to you. Number 5 and 6, find all the zeros. Again, that'll kind of take you through the whole process. Find whatever method fits the best. But on the back side, on the next one, what I want you to take a look at is you can cross off problems 11 and 12. We didn't talk about if you're given imaginary zeros and kind of work your way back from there this year. But you can cross that off, and 10 would be kind of like a bonus type of question. Otherwise, this is pretty much what we just did up here on the board. Okay, without giving you the graph, I'm just giving you the zeros and saying, work your way backwards, turn them into factors, and multiply those out. And I did provide the answers here for you, so you can take a look. So answers to that are attached. The answers to the first worksheet, I put them out on Canvas yesterday, or if during class you want to go through and you just want to take a look, the answer key is up here as well. But these are out on Canvas as well. Okay? Other than that, I'm going to give you time to work, and I'll come around and check on you so that if you do have any individual questions, we can clear those up. All right?